Cross-laminated timber, or CLT, is an engineered timber product that is threatening to upset the dominance of the big two structural materials, concrete and steel. Initially driven by the material's sustainable credentials, cross-laminated timber buildings are gaining traction, as they can be quicker, cheaper, cleaner and quieter to build than traditional structures. Over the past 5 years, the use of CLT in construction has risen dramatically. The material is now being used to construct impressive and sustainable homes, offices, schools and towers. Often referred to as super plywood, the material is constructed in a controlled factory environment from sustainably sourced timber. CLT is manufactured from spruce, although Scots pine, larch and Douglas fir can also be used. Once at the factory, the timber is planed and then kiln dried to reduce moisture content. The conditioned timber is then stacked into layers, known as lamellas, on top of one another. Each layer is placed at a 90-degree angle to the one beneath. These layers are then glued using a non-toxic adhesive and hydraulically pressed together to create the high-strength structural panels. Individual panels can in theory be any size. However, their width is limited by the size of the manufacturing machinery, which is usually around 11 feet or 3.5 meters wide. The length of the panel is only dictated by how it be transported to site. While 45 feet or 13.5 meter lengths are typical for practical purposes, panels of up to 75 feet or 22 meters have been produced. Using state-of-the-art, computer numerically controlled or CNC joinery machines, almost any shape of panel can be produced, meaning that door and window openings can be pre-cut in the factory. These off-site manufactured panels are then ready to be delivered to site. Fabrication is currently limited to only a handful of factories in mainly alpine countries, such as Stora Enso's in Austria. While this may require the panels to be transported to site by road, the embodied energy added to the project is far outweighed by the carbon savings. Proponents of CLT claim that producing timber building components consumes only 50% of the energy required to produce concrete, and a mere 1% of that needed to produce steel. The prefabricated panels can be delivered to site as they're needed, making this construction method ideal for schemes with limited on-site storage capacity. They are then lifted into place using pre-installed lifting straps and rapidly assembled, greatly reducing construction time and therefore cost. As the timber used is kiln dried, CLT should not shrink or warp when on site. However, like most timber elements, CLT must be placed above the damp-proof level and will need protection when used on the external facade. CLT construction can also reduce the self-weight of a structure compared to concrete, potentially reducing groundwork costs. The construction process is also cleaner than traditional methods, with greatly reduced levels of dust. It is also quieter, a distinct advantage for projects built in urban areas. While there are numerous benefits to CLT, some people are fearful of living or working in timber buildings. Some believe these structures have an inherent fire risk, particularly when rising to 10, 20 or 30 stories tall. Unlike unprotected steel, CLT can remain structurally stable when subjected to high temperatures. When exposed to fire, the outer layer timber chars and forms a layer around the structural core, which can retain its low bearing capacity. CLT's inherent fire resistance allows it to comply with fire resistance classes, withstanding blazes for between 30 and 120 minutes, depending on its engineering and formation. CLT uptake and use was initially driven by the material's sustainable credentials. However, in recent times, a resurgent construction market that is placing pressure on traditional materials, along with increased awareness, has bolstered adoption. While early CLT buildings were predominantly small, low-rise structures, the material is increasingly being considered for taller schemes. Since architect Wolf Thistleton built the first timber skyscraper, or ply scraper, in 2009, tall timber buildings have been planned around the world. In the past 5 years, towers of 30 metres, constructed from CLT, have risen in Australia, America and Europe.